Hey guys, so in today's video, I'll be talking about Hess's Law. So I'll be covering Hess's Law, some examples, standard enthalpy change of formation, and standard enthalpy change of combustion. So Hess's Law states that the enthalpy change for a reaction depends only on the difference between the enthalpy of the products and the enthalpy of the reactants. It is independent of the reaction pathway. So the enthalpy change going from A to B is the same whether the reaction proceeds directly to B or via an intermediate. So Hess's law is a statement of the law of conservation of energy. It can be used to determine enthalpy changes which cannot be measured directly. So for example, the enthalpy of combustion of both carbon and carbon monoxide to form carbon dioxide can easily be measured directly, but the combustion of carbon to carbon monoxide cannot. This can be represented by an energy cycle. Hess's law problems can also be solved by using simultaneous equations. So we write the equations that are known and then manipulate them to arrive at the required equation. So for example, this is the first equation where the change in heat is negative 394 kilojoules per mole. And this is the second equation where the change in heat is negative 283 kilojoules per mole. So we subtract the second equation from the first one. So we get carbon minus carbon monoxide, then 1 minus half gives half oxygen, and the CO2s get cancelled out. So the change in heat for this reaction is negative 394 minus negative 283 kilojoules per mole. So after rearranging the equation, you get this equation, and the change in heat for this equation is negative 111 kilojoules per mole. Okay, so let's move on to standard enthalpy change of combustion. So the standard enthalpy change of combustion of a compound is the enthalpy change which occurs when 1 mole of the compound is burned completely in oxygen under standard conditions. So for example, the standard enthalpy of combustion of carbon is the heat released when 1 mole of solid carbon or graphite is completely combusted to form carbon dioxide gas under standard conditions. An important point to note is that enthalpy changes of combustion are always negative as heat is released during the combustion process. So now let's talk about standard enthalpy change of formation. So standard enthalpy change of formation is the enthalpy change when 1 mole of the substance is formed from its elements in their standard states under standard conditions. So here's an example where 1 mole of silicon is formed from its solid state element. An important thing to note here is that the enthalpy change of formation of an element in a standard state is zero. So for example, the enthalpy of formation for Br2 is zero. The enthalpy of formation for Br is 111.881 kilojoules per mole. This is because Br is not bromine in its standard state. Only Br2 is. Another thing to note here is that enthalpies of formation can be either positive or negative. A negative value means that under standard conditions, the compound is energetically more stable than its elements, whereas a positive value means that it is less energetically stable. The usefulness of enthalpies of formation is the fact that the enthalpy change of any reaction can be determined by calculation from the enthalpy changes of formation of all the substances in the chemical equation using Hess's law. So here's the formula. Change in heat equals the sum of enthalpy change of formation of products minus the sum of enthalpy change of formation of the reactants. So standard enthalpy change calculations can be carried out using energy level diagrams, Hess's law, or algebra, in this case simultaneous equations. So standard enthalpy changes of formation and combustion have been measured or reduced for many compounds and are available as tables, so there's no need to calculate or remember these values. They are very useful because as long as we know the values of change in heat of formation for the products and the reactants, we can calculate the change in heat for any reaction, even one which would be difficult or impossible to measure. So here are some heats of formation values. So for example, silver bromide has a heat of formation value of positive 226.7 kilojoules per mole. And here are some heats of combustion values. So for example, acetic acid has a heat of combustion value of 874 kilojoules per mole. Okay, so let's move on to an example. So calculate the standard enthalpy change when 1 mole of methane is formed from its elements in the standard states. The standard enthalpies of combustion of carbon, hydrogen, and methane are negative 394, negative 286, and negative 890 kilojoules per mole respectively. So basically the question is asking you to find the standard enthalpy change of formation given the values of standard enthalpies of combustion. Now the second step is to construct an energy cycle showing the different routes to the products. In this case, the products of combustion. So the first route is from carbon plus hydrogen to the products. And the second route is from carbon plus hydrogen gives CH4 to the products. Okay, so the third step is to use Hess's law to equate the energy changes for the two different routes. So this is the first route and this is the second route via methane. So the last step is to rearrange the equation and substitute the values. So delta H x equals delta H C of carbon plus 2 times delta H C of hydrogen minus delta H C of methane. So if you look back at the question, the standard enthalpies of combustion of carbon, hydrogen, and methane are negative 394, negative 286, and negative 890 kilojoules per mole. So we use that here. So this equals negative 394 plus 2 times negative 286 minus negative 890 kilojoules per mole. This gives the answer negative 76 kilojoules per mole. Okay, so that's it for this video. Thank you for watching.